Hello, explorers, and welcome back to Reach the World's Explorer program. For 25 years, Reach the World has inspired youth to become curious, confident, and compassionate global citizens through virtual exchange. My name is Tim, and I'm so glad you're joining us for today's amazing live stream event. For the past several weeks, we've been following our explorer friend Sara and the Hellenic Arc Volcanic Field Expedition as they collected rock and sediment samples from underwater volcanoes in Greece. We've toured the science labs of the scientific drilling vessel JOIDES Resolution. We've learned all about Sara's everyday life aboard the ship, and we've learned firsthand how scientists work to understand the incredible geological forces that shape our planet. It's been quite the journey. I'm so sad to say that with just 3 days left in this expedition, we're connecting one final time with Sara aboard the JOIDES Resolution today. I'm not sad to be connecting with her. I'm sad it's our last time we get to connect with her. For the teachers and students around the world who are joining us live today, please feel free to use the YouTube chat bar to let us know you're here. We've got at least one class who's ready to ask some on-camera questions when we get there on this call today. So let's dive right into it. I have so many questions for Sara, and it's exciting to think that we get to check in with her one more time. So Sara, I'm going to bring you on screen here and welcome you back to Reach the World. How are you doing?
Good. Hey, so nice to be here. Nice to see you in a few minutes when you get to come on screen. I'm doing really well. We're at our last drilling site of the expedition, so we're collecting a couple final core samples over the next couple days. And then we're going to get off the ship in Heraklion, which is the largest city on Crete.
Amazing. I mean, we started this journey together when many of us were preparing for the winter holidays in the US, and you're still on the ship. You're still doing it 2 months plus later, and just 3 days left to go. Is that right?
That's right. Yeah, it's been such an incredible 2 months. It went really fast and really slowly at the same time. My hair's crazy. I feel like I've gotten kind of in a pirate vibe recently. But yeah, it was good to celebrate the holidays on the ship. I think we talked about that a little bit earlier, and I'm looking forward to doing some big celebrations with all my friends once I get back on land.
Fantastic. You have some pictures you want to show us today, but before we go, I have to notice that there's something new hanging in your backdrop there. Something has arrived that I recognize. Your flag. Awesome.
Yeah. I see your flag in the background.
Yeah, I'm flying mine here. I see some of our classrooms that we'll bring on in a couple minutes have got their flags flying. It's nice to see that the flag has made it all the way to Greece.
Yeah, and I know we were talking about this a little bit a minute ago, but it had to make quite a journey because somebody had to bring it to me on the ship. So it changed hands a couple times in order to get here. So we had some visitors on the boat, and that's how I got my flag with me.
Fantastic. Well, last time we spoke with you, you gave us an amazing tour of the science labs on the JOIDES Resolution. We got to meet some of the scientists who were working to process the core samples that you were bringing up from the seabed. And we just published your final article for Reach the World. And before I switch over to that, I'm going to give everyone the link to that article so that you get a chance to read it. It's fantastic. Including your 3 favorite facts from this expedition, which I won't go into too much. I'll let people discover those in the article. But while we have you here, I want to bring up some of your pictures from recent weeks aboard the ship, and maybe you can sort of walk us through and tell us what we're looking at.
Yeah, so here I am with my flag. I'm at the very front of the ship in this picture. So this is the bow of the ship. We typically talk about ships having a bow and a stern, or forward and aft, different ship lingo. And so you can see in front of us there are these 2 big pulley things that are next to me. Those are actually where we hook on our anchor, or not our anchor necessarily, but the ropes that hold us to port when we're actually in there. I think maybe sometimes we'll lower an anchor with them as well. We don't use our anchors very often because of the type of ship that we are. You can also see behind me some picnic tables where we like to eat meals when it's nice weather. We actually have a barbecue every Sunday when the weather is really nice. So you can't see it in this picture, but on the side of the picture where you can see 2 picnic tables, there's a full-size barbecue on our ship as well. So that's just lovely when you get to have a barbecue outside. We had one when we were really close to Santorini, and it kind of felt like being on a cruise ship, except we were all a little bit tired from working very long hours. And then you see a bunch of teeny tiny windows behind me, and that's actually the bridge where the captain sits and drives the boat. So that's a little bit about what we're seeing in this picture.
Amazing. You mentioned before something called the Steel Beach, where people hang out and relax when they're not working. Where in this picture would the Steel Beach be?
Yeah, that's a good point. It's actually on top of the bridge. So you can see that there's another railing above all of those tiny little windows. And that's actually where the Steel Beach is at. That's the highest point that people go to regularly on our ship. We have a big drilling tower, but people don't go on that because it's a little bit dangerous. So up there on the top, we have a bunch of pool chairs also. So when it's really nice weather, people can lay out there and sunbathe and do whatever, hang out. We did that actually on Christmas Day. It was really nice weather, so a bunch of people got the pool chairs out and were just hanging out and enjoying the sun. And that's particularly important for a lot of people on the ship who work a shift where they only get a couple hours of sunlight every day. So most people are either working from noon to midnight or midnight to noon. And so they only get like half the day with sunlight. So they really try to take advantage of things like the Steel Beach to get their vitamin D in.
All right. I am excited to sort of bring up this picture because we've talked a lot about where you've been and where you are and where you're going. And starting in the sort of bottom right corner of this map, we get a zoomed out view of the Mediterranean Sea. And we can't quite see where you started this journey, but we can see a zoom in on Greece. And we can see some of the places where you and the expedition drilled. Can you describe some of those dots and maybe even tell us which one you're at right now?
Yeah, and actually, so what we're seeing right now is all the different places we've drilled, and actually we're seeing orange and yellow dots, and those stand for either our primary or alternate sites. So sometimes we've had trouble drilling at one spot because of the way that the rocks and sediments are layered together. Sometimes they can be kind of sticky, sometimes they can be hard to get our drill in and out of. So that's why we have backup sites. But all of that to say, also you'll notice that there are a couple different clusters of sites, and they're actually along the three main volcanoes in this region that have erupted throughout history. So this one in the bottom left corner is near the Christiana volcano. And then you can see there's right above that and slightly to the right, there's kind of a half circle shape. That's actually the island of Santorini. And so we drilled in a couple spots there. And then some of the ones above that are near a volcano called Colombo and the rest of the basin. So we're drilling in the rest of the basin as well to see how eruptions from these volcanoes impacted the surrounding region, as well as just what's going on right next to each volcano. And we are actually at none of these sites right now. So we had a lot of crazy stuff happen on our expedition. We ended up adding some sites. So if you see right above the little square map, there's an island. That's, I believe, the island of Anafi. I get my islands a little bit confused, even though I've been here for a while, but we're right next to that island right now. So we added on a site, and that's a big process. We have to talk to a lot of people who make sure that we're considering the environment and considering whether it's safe to drill in that location. So a lot of people had to, and the Greek government, because we can't drill next to islands in Greece without making sure that it's okay with the Greek government first. So yeah, we're drilling at a whole new site now where we can get even more information.
All right. I really like on this map how you can see how each of those three volcanoes in the Hellenic Arc volcanic field are in a pretty straight line. It's easy to see that they're all interconnected in some way that might be invisible from the surface, but seems like there's a pattern going on there.
Yeah, absolutely. Yeah, it's running right along those fault lines that are in this region that are contributing to the things that are helping the volcanoes to form. So I don't remember whether we talked about this last time, but basically there are two big tectonic plates that are crashing into one another, and one of them is diving underneath the other plate, and that's why we have all these volcanoes right here. That's called a subduction, and that's one of the reasons that we have volcanoes forming in this region.
All right. Let's move on to a picture that I was super excited to see because we've talked about Santorini. We've talked about how amazing this his long time ago eruption was that blew the center out of an entire volcanic island. And here it is. Can you tell us what we're looking at here?
Yeah, so we saw on the map, there's kind of a little half circle with a couple openings. So right now the JR, the boat that I'm on, is right in the middle of Santorini, and you can see some little islands kind of behind it. So the ones that are in the center are actually pretty recent islands. Like in the past, I think since the 1700s, those islands have been formed, those little bitty islands right in the middle, by further eruptions of the volcanic system right here. So those are the Kamini Islands. in the middle there. There's still, every time there's like a small eruption, they'll add a little bit of lava and add another little layer. So we've seen some really interesting maps where you can see, oh, this little chunk of the island was formed in maybe the 1740s, and this little chunk of the island, I think one chunk was even formed as recently as the 1950s. So it's pretty cool to think about new islands being built in a time span that we can actually think of as humans.
For sure. And I think, first of all, I love that when you're talking about geology, the 1700s is considered pretty recent. You know, for I think a lot of students, yesterday was pretty recent. But for geology, when you're talking about the whole span of Earth, you know, 300 years ago or so is pretty recent.
Yeah, in geology, 300 years is like 5 minutes. You know, 300 years is really recent for geologists. A lot of the things that the geologists on our expedition are looking at might be as old as 3 million years ago. And even 3 million years ago is considered like pretty near past for a lot of the geologists on the ship.
Great. Now, in sort of the right-hand side of this picture, we can see the caldera of Santorini. You can, I think, students can use their imagination and imagine an eruption that just blew the entire center of that volcanic island out of the middle, and it flooded with water, and that's what a caldera is, created the caldera. Did you get a chance to go inside in that sort of watery area in the caldera of Santorini?
We did, yeah. We actually drilled in 2 different spots inside the caldera. So on both sides, we could kind of see what was happening inside the caldera through history. Because one actually kind of cool part is that, you know, we have an eruption and then we have the middle of the caldera falling down. But that actually happened a couple times throughout history. So the caldera has had some different shapes, and the islands around it have had some different shapes over time as various eruptions have happened.
Amazing. I see some white things sort of on the top of the cliffs around the caldera. Can you tell us what those are?
Yeah, so that was actually a really funny moment when all of the scientists and I first got near Santorini, because we were all looking at it with binoculars from a ways away, because we drilled at some sites where you could sort of see Santorini, but not really well. And I know I, from a distance, thought that white layer on top was another layer of rocks. It looked like a geological layer to me. But actually, that's a town on top of the island. That little white layer is all houses. So if you've seen pictures of Santorini, and you may or may not have, they made a choice to paint all of the buildings there white, and everybody agreed on that. And so every building is white, and it's just so beautiful, and it really blends beautifully into the rocks. So I think it's such a good example of architecture in a way that really adds to the beauty of a place rather than taking away from it.
Fantastic. It sure is stunning. Let's go on to your next picture here. And Mr. Gardner's class, I see that you've got some students who might look like they want to ask a question. If you have someone who's ready for a question, just wave your hand at me and I'll bring you on. All right, I see you. Sarah, we're going to pause for just a second. I want to bring on a student question for you. This is a student from Mr. Gardner's class. Welcome. Go ahead.
Do you have seismographs on your ship? And if so, did you see the Turkey and Syrian earthquake on the seismograph?
Oh, that's a really good question. You know, I haven't heard any of the scientists talking about seeing any results from that. I think the answer is a little bit complicated because we do have some gear on board that can send out seismic signals, and we are, of course, monitoring our drill string to make sure that there's not any sort of vibrations going on that, you know, might indicate that we're causing a volcano to shift or causing an eruption to happen. But we aren't really monitoring seismic data on a wider scale. So I don't think we saw any evidence of what happened in Turkey, but we have a lot of friends on the land nearby who are also helping us to monitor sort of regional seismic changes, because we are really close to a lot of smaller, well, maybe not smaller, we are close to a lot of fault lines where we're at. So basically our friends are helping us to monitor, but we personally didn't see evidence of the recent earthquake.
Yeah, great question. Thank you for asking. If you have more questions, come up and wave your hand again. We'll go back to Sarah's photos. All right, Sarah, what are we looking at here?
Yeah, so here we're looking at a couple different examples of pumice. So on the left-hand side, you can see a really zoomed-in picture of one of the core samples we pulled up from the ocean floor. And so this is all full of pumice. And then on the right, and I'll talk about what pumice is in just a second, on the right we see some pumice floating in the ocean. And pumice is a really cool product that's formed by volcanoes, and it happens when lava from inside the earth is pushed out in combination with gas from the inside of a volcano, and that magma and that lava really traps inside bubbles of gas. So you can see if you look really closely at some of these pieces of pumice that they have little holes in them from where those gas bubbles were trapped, and sometimes you can see that those holes are on the outside, meaning that like, oh, there was some gas right there, but then that bubble popped. Anyway, all that gas on the inside means that these pumice pieces are really light. So sometimes when volcanoes that are underneath the water erupt, they produce a whole bunch of this pumice. And that's what we're seeing on the right side of our screen. So this is called a pumice raft. When a volcano that's underwater pushes out a bunch of these little pieces, and they can be really, really large. They can stretch for miles. And actually, they're really not helpful for boats that are trying to travel through the area, because you can see a boat would have to push through quite a lot of these little pieces. And that might not hurt the outside of the boat, but those little bits of pumice can actually get sucked inside the engines, and that can damage the boat's engines. So if there's a really large pumice raft, this has happened near the coast of Japan, which is where this picture is from. If there's a really large pumice raft, that means that no traditional cargo ships could sail through. You might still be able to sail a smaller sailboat through, but you couldn't really get any big ships in or out.
All right, that's amazing. It's just incredible to think about rocks that are so light that they float. It just like goes against everything you think about rocks.
Yeah, it does. And we can learn a lot about the volcanic eruption from looking at pumices, because they are light, but some of them are lighter than others, and it has to do with what types of chemicals were being pushed out by the volcano.
Okay, how interesting. Sarah, I'm going to bring on some more questions here. We've got a question from Miss Stevens' class. I don't know if you can see it on your screen. I'll read it for you too. They're saying that in science, they've been learning about weathering and erosion. Did you notice any erosion during your expedition in Santorini or elsewhere?
Oh, that's a really good question. And it actually kind of points to a bigger thing about why do we drill into the ocean at all? Because the answer is that on Santorini, you can see a lot of examples of weathering. And actually, one funny thing is not only can we see all of these different layers of volcanic eruptions on the islands of Santorini, but we can see places where those layers were damaged by weather or even by people. So we can see some of the ash layers from different volcanic eruptions have actually been used in construction in various parts of the world. So a lot of times our geological record is impacted on the land, and other expeditions, maybe not necessarily ours, but other expeditions on Santorini have seen evidence of that erosion. However, we're drilling underwater partially because there are processes going on underwater that can change how different geological layers are deposited, but oftentimes you get a more complete record of the history of the region underwater. So that's actually why we're doing our drilling underwater instead of on land. So really good question.
Yeah, fabulous question. I see we've got another student from Mr. Gardner's class who's got a question for you, so we'll bring him on. Hello, go ahead.
What do you think the future of volcanism is in the Grecian archipelago? Like, do you think it'll maybe within the next millions or tens of billions of years? Do you think it'll maybe migrate north into the Balkans and South Central Europe?
Ooh, so I think I had a little internet glitch, so I heard part of it. Are you asking if the volcano would migrate into the Balkans and South Central?
What do you think of the future of volcanism is in the Grecian archipelago within the next tens of millions of years? Like, it will migrate into the Balkans and Central Europe?
Oh, wow. That's a really good question. And I'm not sure I totally know the answer to it. What I can say, though, is that we're in a system that's called a arc volcano system. And actually, one of the characteristics of this type of volcano system is that the volcanoes do move over time. So I told you that we were drilling next to 3 different volcanoes. One of them is really old, and it hasn't had any eruptions for a very long time. Santorini, the volcano that's underneath it, has had some eruptions, like I talked about, even very small eruptions as recently as like the 1950s. But the volcano that's just a little bit north of Santorini is the most active one right now. So it's been moving along what's called a hotspot track. So I don't know about exactly where the volcanoes will move next, but the answer is that, yeah, very slowly over time, we will probably see the volcano that's the most active moving.
Fantastic question. Thank you so much. Let's bring up this interesting photo. Can you tell us what we're looking at, please, Sarah?
Yeah, so this is another picture of a pumice, and it's a little bit more zoomed in so that you can see a little bit better a lot of those bubbles that I was talking about. So places where As this magma was being pushed out of the earth by a volcano, it was trapping gas bubbles. So you can see a lot of little remnants of where those gas bubbles might have been. Looking at this is just a better example. I think this is a bigger piece than a lot of the pieces that we're seeing in our cores. We're seeing really small little bits of pumice. This one, as you can see, I believe that this is in inches. It's a much bigger piece of pumice. So there are all different types of pumices that can be found in various different types of volcanoes. And actually, I was talking a little bit about how the gases that are inside the pumice can tell us a lot. And one of our scientists here on the ship is looking at just that. She's looking at how much gases did our pumices have, and how does that change how much they weigh and whether they floated or not. So eventually some of her research might be able to tell us, oh wow, when these volcanoes erupted in the past, did they have a big impact on people's lives who were working with ships? Things like that.
That's really cool, Sarah. I have a quick question for you. I know that when you pull up a core from the bottom of the sea, that it's exciting to see what you get. And I'm sure that the scientists are noticing things right away. Do you have a sense of how long it will take to really thoroughly investigate the clues that this expedition has been pulling up from the bottom of the sea, and how long it takes after the expedition to really analyze what you found?
Yeah, that's a really good question, because this is actually a super long process in the sense of how we might think operating in school years. So we spent 2 months on the boat, and in that time we pulled up 4 kilometers of core so far. We might get a couple hundred more kilometers, or not a couple hundred more kilometers, we might get a couple more 100 meters before the end of the expedition. But you can imagine that's almost 3 miles, so if you think a 5K is a 3-mile run, we've got 4 kilometers. So pretty much everything that the scientists have been doing on the boat is to describe that core and to take some very rough measurements of it. So we had some meetings on the boat the other day, and the scientists were talking about how their big paper, the paper that pulls all of their data together, it probably won't be published until sometime in the middle of 2024. So they're probably going to have some shorter papers that focus on just one small aspect of their data in the next couple months even. Some aspects that are really exciting and that they want to get published really fast, but their kind of overarching synthesis of everything that they find will probably not be until next year at the earliest.
All right.
One of the scientists said that he worked on stuff from his last expedition for 5 years. So it's a lot of data.
Amazing. Yeah, it's a long process of understanding. I see another student with Mr. Gardner's class ready to go. If you're ready to ask your question, go ahead.
According to your research, are underwater volcanoes made up of different composition than land volcanoes?
That's a really good question. Oh, I wish I had one of my scientists with me to answer that question. I will say that all of our I think the answer is yes, probably, because every volcano that we see that we're studying, so we're studying those 3 different volcanoes, they each have a slightly different chemical composition from one another. So we have scientists on board who are called geochemists, so chemists that are specializing in geology, and they can tell us, oh, did this piece of pumice come from Christiana or did it come from Colombo, because of the differences in the elements that they find in there. So I think almost every volcano, and even different eruptions from the same volcano, can have different chemical compositions. Great question. Oh, I see a question. What is your favorite place or favorite experience from this expedition? Ooh, I think so. My favorite place was probably the inside the caldera. We were really close to land there, so we could see all the beautiful houses with the white buildings, and we could see the beautiful layers of different volcanic materials on Santorini. So when you look at the side of the island on Santorini, you can see a bunch of different layers, and lots of those layers were made by volcanic eruptions. That was my favorite place. My favorite experience is probably just the sunrises and sunsets. If you've spent time watching sunrises and sunsets, they're very beautiful, but at sea, they're totally different than on land, because you get, a much longer time to experience them, and you don't have anything interrupting your view. So they're just really beautiful and unique.
Excellent. All right. I love the student questions. Great questions, students. Keep them coming. Sarah's got a couple more pictures to show us, especially this one, which came through in one of your last articles, Sarah, and we touched on it really briefly. But can you remind us what these scientists are doing in this picture?
Yeah, so you can see this person in the green sweater is my friend Allie, and she has a toothpick in her hand, and she's just taken a little swab of the sample that's in front of her. So you can see that long tube that's right there on the table is a core sample. And so she's taken that toothpick and dipped it into the core and has actually stuck it into her mouth. And the reason that she did that was because based on how the core sample tastes, she can tell a little bit about what its composition is, because she's tasted a lot of rocks so far and a lot of sediment samples. And she can actually grind her teeth on whatever, she's put into her mouth. And that tells her a little bit about the size of the grains that are inside the sediment. So yeah, she can learn a lot by putting sediment samples into her mouth, which really surprised me when I first learned about it, because I thought you never put anything in your mouth when you were doing science. But in this case, you can.
Yeah, that is so interesting. Let us move on to your next picture. What are we looking at here?
Oh yeah, this is a really cool type of core sample that we saw. So even though the scientists are really looking for evidence of volcanic eruptions on our expedition, with this sample, they're just looking at what they call an ooze. So this is something that forms over a long period of time, and it's kind of a normal sediment sample, but we see these stripes going across it back and forth. These stripes are kind of a light tan or a white color. And that's actually the fossilized remnants of a worm munching through this sediment layer and pooping out some sediments that it had previously eaten. So it's crawling through this dark brown layer, and before it had eaten the tan stuff, and this is where it pooped it out. And we can see the type of worm or a class of worm that might have done this over on the right side. So this is a bristle worm. And there's a whole bunch of different types of marine worms, but we think that this type might have been the one that's responsible for this pattern. So these are very beautiful, and it's so funny to me that they came from worms pooping.
That's amazing to think about. I see another student who is ready with a question. Mr. Gardner's class, when you're ready, go ahead.
What was the most important, or like the one where what was the most important drilling that you had, or like the one where you learned the most?
Oh, that's such a good question. And I think the scientists on board would have different answers depending on who you asked, because a lot of the scientists are interested in those volcanic eruptions. So some of them are really interested in all of the core samples that we pulled up that were next to Colombo, because that's one of the more active volcanoes. So they were all really excited about that, and they are all learning a lot about how many times that volcano has erupted from those samples. But one of my other friends studies a certain type of layer called a sapropel, and that's a layer that's got a lot of organic matter in it, and it's important, and because it has to do with the way the Earth cycles. So she was really excited about some of these sediments that don't have anything to do with volcanoes. So she was excited about some of the stuff we pulled up from the basins that were further away from the volcanoes. But yeah, really good question. There's been a lot to learn.
Fantastic question. Thank you so much for that. Sarah, I'm going to bring up your pictures. I think we're almost to the end of your pictures here, but we have what looks like maybe one more worm to talk about.
Yeah, so this is just a different type of that same effect that we saw with the other sample. This worm is a lot smaller than the worm that we looked at last time. So you can see we're looking at this worm. It's a little marine nematode under a microscope. But that other worm you probably could see with your naked eyes just in the water. Well, you wouldn't see it in the water. It lives in sediments. So if you were to dig underneath the ocean, you might see some of those. But you can see those those tan streaks in our sediment that are against the much darker background. Those are evidence of this much smaller worm burrowing through the sediments and pooping out the lighter colored sediments. So you can see a lot of records of different types of worm activity in some of the cores that we've pulled up.
I think it's just further proof that though we sometimes think of poop, especially historical poop, as bad and gross, it's certainly giving us a lot of information in this case. So it's also quite valuable. I wanted to end with this picture, Sarah, mostly just to show and remind everybody who's following this expedition that you have been creating some amazing articles during your time on board the ship, including the most recent sort of farewell journal that we just published with some of your final thoughts from the ship. And you can see under journals on this picture that it includes your 3 favorite volcano facts, which for especially Mr. Gardner's class, who seems to be doing a deep dive into volcanoes, I think you might find some of Sarah's comments there especially interesting and helpful for your study. So with that, we can bring it back to just you and me. I have some questions. We've talked a lot about the science. We've talked a lot about where you've been and what you've done. Did you have a favorite food that, I know we asked you this question early on, has something popped up in the menu that has, really been like, it kept you going, reminded you of home, something delicious that you've had on board the ship?
Oh yeah, I'm trying to think. There's so many good meals that they make that it's hard to pick out just one. But and I feel like this might have been my answer right at the beginning also, but they make these peanut butter chocolate bars every now and then, and it always seems to coincide with the day that I'm like the most tired or the most just like ugh, I just kind of want to be at home today. And they always seem to make this peanut butter chocolate bar on those days, and it really gets me through the rest of the day. But then there's this one like steak meal that they make where they have a little steak and then this sauce that you put on the steak, and they always serve it with onion rings. And that, for some reason, just really hits the spot for me also. So those are the two things that I like the most.
It brings me back to one of your first articles when you were showing us what you were packing for this expedition, 2+ months ago. And you were asking us, the audience, the students who are following you, if we thought that you were packing enough chocolate. And it sounds like chocolate proved to be the uplifting fuel that you thought it was going to be.
Yeah, it really did. And I did pretty well. My chocolate stash, I managed to have some self-control, so it lasted up into week 7. But then I did burn through it. And so this last week, I'm scrambling a little bit.
All right. Well, we've got another student at Mr. Gardner's class who's got a question. When you're ready, go ahead.
What are your plans after this expedition?
Oh, sorry, I didn't hear the first part.
What are your plans after this expedition?
Oh, yeah, that's a great question. So right after the expedition, I'm actually going to go on a hike with my mom and my best friend from home. I'm really excited about it. We're going to be in Greece for a couple days, hiking through the mountains. But then after that, I'm actually just going to go to my regular job. So I took a break for 2 months to come do this, but then I'm going to go back to my other job. So I'll be helping journalists to write about science, which is what I do most of the time. I really like it, but it was fun to be on a ship for a while.
What was, Sarah, over the course of your meeting, thanks for that great question, Mr. Gardner's class. Over the course of this expedition, we talked a little bit about the different jobs you can have in exploration. Were there any sort of roles or people on the ship whose job surprised you, or you thought, wow, that is an interesting way to get involved in this kind of work environment where you're at sea, you're on expedition, you're investigating the world? Do you have any examples of that?
Yeah, one of my friends that I've made, because since I'm doing all of these broadcasts and I'm talking to people off the ship, I spend a lot of time thinking about our internet connection. And so I've been talking a lot with the 2 people on our ship who are responsible for IT. So you probably think about at your school, at your parents' work or your guardian's work, there's somebody who's making sure the network works right, making sure that you have the internet, or if something goes wrong with your computer, they're there to help with that. And our boat is kind of like a small city or a small workplace. So we have some people on the ship who are responsible for all of our IT problems. And I thought that was really cool. And I'd never thought about the fact that you could be an IT professional that sails. And they're really cool people, and they do a great job of keeping all of our computers working and keeping us connected to the world as well as we possibly can be out at sea. So yeah, it kind of made me think, oh wow, if you're interested in computers, you can also go to sea if that's something you want to do.
All right, fantastic. I think I see another student from Mr. Gardner's class who's ready to go. I'll welcome you on. Whenever you're ready, go ahead.
What are the biggest questions for geology?
Can you say that one more time,
Biggest
please?
questions for
What are the biggest questions for geology?
Ooh, that's a big one. I don't know whether I can answer for quite all of geology, but kind of more generally, geology is looking at all of these different things that have happened in the Earth's past. Why are continents moving around? How is that happening? What are these volcanoes doing? What might have caused them to erupt in the past? And I think one of the cool things that I'm learning about earth science and about geology is that people are starting to try to think about a lot of these same things that are happening on Earth on different planets, on planets that might have some similarities to Earth. And so I think there's a lot of work that NASA is going to be doing in the coming years that's asking some kind of geological questions about other planets. So cool things to keep your eyes on.
Great question again, Mr. Gardner's class. I think very likely that somebody in Mr. Gardner's class could be on the team at NASA who is investigating rocks on other planets. It's exciting for me to think about. Sarah, do you think you'll go on other expeditions after this?
Oh, I would love to. I think that would be really cool. It's quite a process, as you probably know, Tim, to get on these expeditions. There's so many months of planning that goes into them, and you have to plan your personal life too to be able to leave for 2 months. So I would love to, but it'd probably be a couple of years before I could go on another expedition, just because even after I applied, it would probably be a year before I would go on the expedition. But yeah, all that to say, I would love to. I had a lot of fun, and I learned so much, so it was great.
Fantastic. Yeah, well, we learned a lot from you. So I hope that you go on other expeditions and we can follow you on those expeditions, because you were great at explaining and showing us what you were doing on the ship. And we could learn about geology, we could learn about life on the ship, and all the fun things that we've covered. Will you tell us about the next 3 days? I know that the team on board the ship is frantically trying to get as much core sample on the boat as possible. What happens after that?
Yeah, they're going to be doing that kind of right up until the end of the expedition. So I'm thinking today is, for us, it's Tuesday night. I think most of you are probably based in the States, where it's probably sometime during your morning or during your day. We're about 7 hours ahead of the East Coast of the United States and 10 hours ahead of the West Coast of the United States. So that means tomorrow on Wednesday, the scientists will all be collecting those core samples. They'll be trying to write down all the notes about them so they know what we have once we leave the ship. On Thursday, though, the labs are probably going to start to close. So the people that are on our technical staff, so the people that are actually employed by the ship to keep all of our lab equipment running well and to make sure that the scientists who just come on board for 2 months know how to use our lab equipment. So those people, who are the staff, are going to be cleaning all the labs. Oftentimes, after one expedition ends, there's another expedition that gets on right away. That's not happening right for our expedition. So we have what's called a tie-up period in between when our expedition ends and the next one starts. That means that the boat is going to be in port somewhere, and they're going to be doing maintenance and just kind of all the basic things that you need to do to keep a ship safe. So you can imagine if you had to take your car into the mechanics for a really long time because it had a lot of problems. Our ship doesn't have a lot of problems, but we're doing lots of maintenance to make sure it doesn't get any problems. So that's what it's going to be doing next. But yeah, once we start cleaning up the labs, then the scientists will be writing up final reports. So we publish right at the end of an expedition a record, not of the data that we collected, but kind of what we did while we were out at sea. So they're trying to make sure all those reports are written. And then we're going to have a big party once we get on land. So I'm really looking forward to that. We're all going to go out and eat together in Crete.
Fantastic. It will be nice to have your feet back on solid land, I'm sure, and celebrate all of your successes. I see a student waiting very patiently in Mr. Gardner's class. Thank you for waiting. Go ahead.
What are the largest dangers associated with your expedition?
Ooh, the largest dangers. I think we tried to account for as many of them as we could. Probably what you can imagine the worst scenario would be is if somehow our drilling jostled a volcano and that it would erupt. There's really no chance that we would do that because we had a bunch of scientists look at all the data we could find ahead of time to make sure we weren't going to drill too close to a volcano. There's actually also some dangers associated with hitting gas, so the gas oil companies are drilling for. Actually, our ship used to be an oil drilling ship, but we took out all those parts when we converted it for science. So if you hit a pocket of the type of gas that we put in our cars, it can actually push back up on the drill, and that can be dangerous. So that's actually probably one of our bigger dangers, but we're always checking our samples for evidence of gas as soon as they come up from the seafloor. So if we saw any evidence of gas, we would back up right away and we'd go to a different spot. So that's probably the biggest danger we face, but we do everything we can to avoid it.
Great question. Let's roll right into another student, Mr. Gardner's. Go ahead.
What was the most challenging part of the mission?
Ooh, the most challenging part? Oh, I think honestly probably being away from my friends and my family for such a long time. I had a lot of friends that I made on the ship, which was really great, but especially for the first couple weeks where you're still kind of getting to know everybody, it felt a little hard at times. And then you're kind of in a confined space, so you don't get to leave. Sometimes if you're kind of feeling frustrated, you just leave a situation. But we couldn't really do that. However, we do have a lot of spaces where we can find personal time if we need it on the ship. So I think that was for me the hardest part. And working long hours. We work a lot, but it was great overall.
Right. Thanks for that great question. Mr. Gardner's class, you're really dropping some great questions today. I'm going to take you off screen, but if you have more, we've got a couple more minutes with Sarah before she's got to go. And come on up to the front of your room if you want to ask them. That'll be my visual cue that you're ready to go. Sarah, we have learned a lot about geology, specifically with this expedition. You are a general sort of science communicator. You just like to explain science things. In addition to the ideas that or the points that you brought up in your farewell article, are there any just like super interesting facts or things that you learned during your last few months on the ship? It doesn't have to be about geology. It can just be about anything.
Yeah, I'm trying to think. This one is kind of about geology, but I don't think I really understood how many different types of geology there were going into this expedition. So one of the cool parts about our trip is that we have a bunch of scientists who have different subspecialties. So like they're all sort of in the realm of geology, but they do slightly different things. So we have some people that are experts in rocks. They know every time we bring up a core sample, they can look at it and be like, oh, this is a piece of breccia or something like that. And then they'll say a word that I'm not even sure I've ever heard before, and it will be a word to describe that particular subtype of rock. And actually, Allie, the person that you saw eating the sample, she's one of those type of geologists. So she knows everything. I feel like she knows everything there is to know about rocks. I'm sure she would not say that, but she knows a lot about rocks. And then there are geologists that just look at how the rocks are shaped, kind of, and they're trying to figure out if the rocks moved against each other on a fault line. They're called structural geologists. I'd never heard of that before I got on the ship either. So I thought that was really cool. And then there are some geologists that just study volcanoes. We have a lot of those. There are some geologists that just do chemistry. So I talked about how there are, like, you can tell which eruption certain materials came from based on their chemical composition. So there are just those types of geologists. So even within a field that sounds pretty specific, like geology, there's a lot of different things you can do within geology. Amazing. And that was amazing to me.
Very cool. I see a student question ready to go. Mr. Gardner's class, whenever you're ready.
What are your best discoveries on the ship? For example, new rocks or more volcanoes?
Ooh, what were our best discoveries? Well, I know a lot of the scientists would say they found some new volcanic eruptions that they didn't know had been there before. And I can't really say anything else about that because it's a secret right now until they publish it. But they found some new eruptions, which is really exciting. It's kind of to be expected. You know, we didn't have a complete history of what had happened with these volcanoes before this trip. But we also found some special types of rocks. I know one that they've been talking about recently is called serpentine. And it kind of looks like a countertop to me, honestly. So if you've seen those countertops that have a bunch of different lines through them and kind of a green and a white pattern, that's what it looks like. So I thought that was really cool. But it looks like you have another question.
Yeah, go ahead if you're ready.
What did you learn about radioactivity in volcanoes during this expedition?
Ooh, did we learn about... You know, I don't know whether we learned much about radioactivity itself, but we actually used some of the particles that emit very small amounts of radioactivity to learn what layer the different products came from. So we were using radioactivity to tell us, is this layer from the section we thought it was from?
Are there discoveries you wanted to discover out but you couldn't?
Oh, you know, yeah, there were some. So the scientists had an idea of how many eruptions they thought this one volcano had, and they had an idea of how deep we might have to drill to be able to find that whole history. And they did this by like shooting it something kind of similar to an ultrasound into the bottom of the ocean floor. So they kind of get a rough map of what's going on, and then we match our core samples to that map. But we weren't able to get down as deep as we wanted to because the drill got stuck. So some of those ash layers are kind of sticky. So we had to pull really hard to get it out. And then we decided we might get stuck forever, so we better leave. The scientists were a little disappointed about that. But maybe someday they'll go back and be able to get those samples.
Oh, it must have been so hard to be so close and then have the drill stuck in that one spot. All right, student question, go ahead.
Are there any new or interesting facts about organisms that you have discovered while on the ship?
I think the answer is that we aren't really sure yet. So one of the scientists on board was taking samples for microbiology research. So she was specifically looking at how did microbes respond to these volcanic eruptions. And so she took a bunch of samples, but she's still actually growing up any surviving microbes and taking genetic information from the ones that might have already died. So we'll have answers on that pretty soon, but not yet.
Hello. What amenity, like when you were on the ship, was the hardest to give up?
Oh, that's a good question. I think for me, even though we have an internet connection, obviously, that we're using to talk to you, we aren't able to stream on Netflix or stream YouTube or stream like Spotify. So we had to download all of that ahead of time. So we kind of had to try to predict what we might be interested in watching. And there's a big library on the ship of like movies and TV shows and things like that. But it's just, it's a little different than being able to hop on Netflix or another service whenever you want to. So I really miss being able to do that.
Fantastic question. Any other questions from students in Mr. Gardner's class? No, we got Sarah answered all of your questions. All right. Well, I'm really happy. I'm very happy to hear that we've answered all the questions. We've covered everything, Sarah. You did it. Good work. And with that, we're right at the end of our time that we have with Sara today. As she said, she's in her final days aboard the JOIDES Resolution. The Hellenic Arc volcanic field expedition is coming to an end after more than 2 months at sea. And I just want to thank you, Sara, on behalf of all the students and classrooms that have been following you on this journey. Thank you so much for taking us with you and for teaching us so much about underwater volcanoes and geology and living and working on board a ship. This has been amazing.
Yeah, thank you. Thank you all for joining me on this trip. It's been so much fun to share what I've been learning with all of you, and I've loved doing it, so thank you.
Excellent. I'm going to add one more time to the bottom of our screen the link that you can follow to see all of Sara's virtual exchange articles on her Reach the World Expedition homepage. And Mr. Gardner's class, I'm going to bring you all back on camera too so we can say a big goodbye and thank you to Sara. So on the count of 3. Thank you so much, Sara. Bye, everyone.
Bye.